I saw Sue for the first time at a recent SIG-IR meeting where she gave a very nice talk about how it would be nice for us not to bother with knowing what's where in our computer, that the computer will just know where everything is and give it to us when we need it. It's quite an inspiring talk, and that's what inspired me to ask her to come here and talk. And when I told my colleagues that I wanted to invite Sue Dumais, they said, "Oh, Sue, yes, of course." And it's because I hadn't realized at the time, but fame far precedes her. She was the past chair of the ACM SIG-IR. She has been on various ACM journal editorial boards, and she's on the National Research Council for the Committee on Computing and Communications Research to enable better use of information technology in digital government, and on the NRC board for the assessment of risk programs. And all these accolades, of course, have followed other very interesting work. I actually used to know her work. I know her work about latent semantic indexing and its use in rapid information retrieval and other things of that nature. And she's also very active in general in human-computer interaction and its use in computer systems. And she's right now with the Microsoft Adaptive Systems and Interaction Group, and before that she was in Belco Labs and so on. It's a pleasure to have you.
Thanks. Thanks for the opportunity to speak. As Sanjeev said, my work is probably a little bit at the fringes of what goes on in this center. So this talk is mostly going to be on information retrieval with some aspects of human-computer interaction. And I've already met with several folks today and hope during the questions and answers to get perhaps input on how this might be augmented with speech data, maybe NLP analyses and things like that. So that's one of the things I'm hoping to get from here is sort of input about how we can do things more richly than our current focus on strictly information retrieval-based techniques. So you can find out a lot more about this work as well as other things on my homepage. So what I'm going to do today is talk a little bit about search as it exists today, talk about search with stuff I've seen. This is joint work with colleague Ed Cutrell and Raman Saran at Microsoft Research. And then I'm going to tell you mostly about our experiences in deploying this. We've deployed it internally to about 1,500 users. And you get a lot of feedback of various kinds. So I'll tell you a little bit about evaluating it in the wild. And then I'll talk about some of the implications that systems like this might have for file management in general, or information management in general. Okay, so today, when you think about searching over information you've seen before, it's really a mess. Basically, every application has its own interface. There are different techniques and different storage hierarchies for finding web information, mail, local files, and so on. So if you're on the web, you have this interface, a standard browser interface. You may have favorites. You may have invested some time organizing them. If you go to, this is a file system, you have yet a different interface to search, a different folder hierarchy. If you add on top of that a mail client, you have yet a third folder hierarchy and another interface for searching. Microsoft, in their recent tablet, has provided yet another interface for storing notes and searching against them. So basically, every application you encounter has its own way of storing and organizing information, which is, from the user's point of view, tedious at best and confusing at worst. Also, these systems are often really slow. They basically don't provide the sort of indexing that the web-based search techniques that you're familiar with. So the experience is really a mess. The chief software architect at Microsoft said it best. The number one question we're trying to solve in the next version of the operating system is, where's my stuff? Right now, the space on any PC is a cesspool. Okay, I didn't make up this quote. So what we tried to do with stuff I've seen was rectify that situation. Basically make it easy for you to find information regardless of where you've seen it. Right now, in order to find something, you first have to remember whether you saw it as an email, a web page, or whether you put it in a file or a program. What we'd like to do is just get rid of the fact that you have to know where you saw it. Make it a unified access to everything you've ever seen. Computer, calendar, contacts, web pages, files of all kinds. The other thing we're going to do is build a full content index of it, the standard sort of inverted indices that web search engines build so that search is really fast. I think that dramatically changes the way that you interact with information. So it indexes the full content of everything and anything you've ever seen, as well as its position and any metadata that we have. So some applications generate nice metadata, others generate less clean metadata. The next thing we do is automatically and immediately update it, so you don't have to do anything. Just continue working as you're working, and we'll make it really easy for you with this background indexing to get back to things that you've seen before. And then the thing that I like, given my background as a cognitive psychologist, is the fact that because it's your content, I think there are lots of really interesting UI opportunities. You can do very different things with the retrieval interface than you can do with standard web search. And then I guess the last meta point is that a lot of search tools right now are aimed at information discovery. But in fact, a lot of knowledge work is not discovering information, but reusing it. If you look at reaccess patterns for web pages, 70 to 80% of the pages you visit are things you've seen before. I'm sure the same is true of documents and papers. You keep going back to the same stuff, and what you do is reintegrate and organize in different ways. So we really want to support that much better than we currently can. There is a fair amount of related work. It's referenced in the SIG-IR paper in detail, so I'll point you to that. Let me just mention a couple that are interesting. David Galertner and colleagues at Yale built a system called LifeStreams about almost a decade ago. And the idea there was to change the file system from one that was file-based to one that was time-based. They very much stuck to the time metaphor, which I think limited the applicability early on. A lot of that has evolved into a company called Scopeware that David is involved in. There's a project called My Life Bits at Microsoft Research in the Bay Area. Gordon Bell and Jim Gemmell have done this. This, again, is worried about helping you refine and reuse information that you've seen before, except instead of focusing just on information that's easily available digitally, which is going to be my focus, Gordon has actually gone and scanned his entire life. I mean, all his papers, awards, records phone conversations. He is making his life digital and then looking at both architecture and application interfaces that arise in that. And then the thing that's probably closest to it in spirit and in implementation is the Haystack system at MIT. David Karger is the main PI for that. There are also some commercial products that do things kind of like this. So both Mac and Windows ship with indexing infrastructure. They tend to be much more limited than what I'm going to talk about. And then there are some third-party applications that you can buy for, I don't know, $49.95 that index everything on your hard drive. So what's new with stuff I've seen is that we're indexing the full content and metadata from many different sources. They don't have to live on your hard drive. Regardless of where the information lives, we'll provide unified access to it. It's also an extensible architecture. And then again, our focus from a research perspective is not so much to deploy and support a system, but to understand what users' experiences are in living in a system like this. And so I'll talk a lot about that today. Okay, I want to say something about the architecture. I have this in one slide to make you believe that it's real, but that's not the focus of this. There are, this is a fairly standard indexing architecture that we built this on. There are 5 main components, and 3 of them are extensible. So the first component is a gatherer. It specifies how you grab a blob of something to index. It can index files. MAPI we use to index mail. It's a mail API. You can use HTTP. If you have some other stream of information that you want to grab, you can write a pluggable gatherer that basically specifies how to get a unit of analysis that you care about. The next part is now that you have this blob, you have to take it from its binary form and transform it into a stream of Unicode that you can actually build an inverted index from. And so there are different filters for PDF files and HTML and the handwritten journal and tablet and so on. Yeah.
Quick question. Gatherer, so if I wanted to, let's say, index all my phone calls, what would the interface to gather?
So where are your phone calls stored?
Let's say my voicemail.
So you have to write something that specified how to grab an individual voicemail message,
Okay.
then a filter that would say, here's how to go from this binary format to a stream of Unicode that I can index.
So the recognizer would be a filter.
The recognizer would be a filter, right. And we actually take the handwritten notes that the tablet folks do. They've written a recognizer that's going on in the background, and we just index it. Adobe has written a filter for PDF. I have no idea what their binary format is, but they do, and so they can spew out a stream of text across the index. So yeah, the gatherer specifies how you grab the content, and the filter specifies how to transform it to something that you can index. Yeah.
But you're assuming that the stuff you can index is text, right? So music indexing, for example, would be a kettle of fish, although you might.
That's actually a really interesting question. So we index the full content plus metadata. So if you want to spew out some metadata, we'll be glad to index it. So for a lot of MP3 files, there are filters that take that and spit out metadata, like the title of a song, the...
Sure, right, what I had in mind was the sort of humming query stuff. That's
correct, we will likely not support that in the near future. So we can grab any metadata that you're willing to spew out, and it could be, attributes like contains high variance in pitch range or something like that. Yeah.
In terms of image primitives, do you have any graphical query capabilities?
No. Right now the interface is only text, but that's limited mostly by the filters that we have because they're not representing anything interesting in terms of images or graphics. Okay, so after now you have a stream of Unicode. There are tokenizers that break things into words. There's a standard inverted index, and then there's a retrieval system that's a fairly flexible system. It does some probabilistic best matching using a OCAPI-based technique that Steve Robertson in Cambridge developed, as well as Boolean retrieval. There's also the user interface to talk to all of this, and the other thing I should note is all of this happens client-side. So all the indexing and retrieval happens client-side, which again provides a lot of computational horsepower. This is an architecture, it's real, it works. No, I mean, you don't really care, right? It's a standard, gatherer, indexer, database, all the pluggable components. It's mostly the pieces I talked about. The gatherer and filters are important. You're probably also interested in word breakers. You could do things like extracting entities that you could put into the stream and tag them in various ways as well. Okay, so we have a couple, so that's the back end. We're going to index everything you see and provide quick access to it. There were a couple of design principles that we had in building the system. The first was on the indexing end of things. We wanted it to require absolutely no work on the part of the user. We did not want the user to say, oh, this looks like a really cool web page. Maybe I'll return to it later, as you do with favorites today. We just wanted it to happen. Okay? I think it qualitatively changes the experience when you force people at the time they see something to decide whether or not they'll want to index that. So the user does nothing, indexing just happens. On the retrieval side...
Speaking of favorites, that means that you would save the web page, but you would then refresh it. I mean,
we save an index to the web page. The web page lives wherever it
as
is.
it was when I looked at it.
When you looked at it,
Not
yeah.
as it keeps changing.
So that's actually a great question. So for the web, what we do, and the default changes. By default, I think we go to the live web page. If that doesn't contain what you want, you can go to the cache version, which is what you saw. And it turned out we decided to go to the live web page rather than the cache version because people actually like to operate on the live website. And most of the time what's there now is similar to what you saw. But you can see either. Okay, so you can either get back to what you saw literally or to its current live version. And that's a case where initially we allowed people to go back to the cache, which is not what they wanted. They wanted the live site. So we just changed the default. When you deploy, right.
So for example, if the filter comes up with a title tag for the document.
Right, then we'll have a title field. I've only shown you a limited number of fields. There are these are some of the columns we support.
Okay,
so if there are properties that are extracted, then we'll typically make it a column and allow you to search for that or filter on that. Okay, so fast, flexible, unified. Let me tell you about what happened when we use this. So evaluating this is really hard. I come from a psychology background where you do a lot of controlled laboratory experiments. I've been in information retrieval for the last 15 years where you do Trek style evaluations. You have a golden set. This is not like that. We've deployed it internally. We have about 1,500 people using it. And they're not just geeks. In fact, they're mostly not geeks. They're people who are out in the field doing sales. They're administrative assistants. They're all sorts of people. So I think we're getting, given that we're starting with a Microsoft population, we're getting a pretty reasonable sample of people within that. And then we've tried a whole bunch of different techniques to try to understand how people are using it, what techniques work and what techniques fail. The first is we get free-form feedback. So we have a feedback alias. If you blow something big like fuzzy search as a default, you know it immediately. So within 20 minutes of when you've deployed this, you'll know it. The other thing we've done is some questionnaires and structured interviews. What I'm going to talk about today are three kinds of studies that we've done. One is that we look at the usage patterns from log data. So we record all the interactions with the client and a little bit of information about what's open. We know the time that the item was created and its type. So we know a little bit about what people are doing. We don't know anything about their store. We've also done some user interface experiments, as I said, in the wild, where we randomly deployed different versions. And then the last thing we've done is, for some richer interface techniques that we've looked at, we've done some controlled laboratory studies. So this is some detailed analyses for 230 people that we did about 6 months ago. We've now redone this on 1,500 people. So basically multiply all the numbers you see here by 10, and things really still work. So people's personal stores tend to be about 5,000 to 100,000 items. Here's a look at my world. I have in my store, this is on my laptop, I have about 1,000 web pages, 20,000 files, which take up most of the size, and then about 50,000 emails. So my total store is 71,000 items, almost 10 gigabytes of disk space. The index for that is only 190 meg, right? Because all we care about is the text. We don't care about the image or music or anything like that. And the index size increases at about 1.5 meg a week, given my normal flow of email. So this is I think given the size of modern disks, this is something that's eminently manageable. The query characteristics are amazingly short. On the web, people's queries are 2.1 to 2.3 words. They're shorter here. I think there are a couple reasons for that. It's much less stuff to search over. It's your stuff. And thirdly, you can iterate really quickly. You can refine your query if it doesn't return what you want. But people here are issuing really short queries on average. They use almost no advanced operators. Nobody's using ands or ors. Quotes is the most popular, so people will put quotes around phrases. But although people don't specify complex queries up front, they do iterate a lot. So almost half the queries involve some sort of iteration. And that iteration can be filtering the query by type or date. It can be retyping the query, changing the query to add or remove words, or refining the query by resorting one of the rows. So people iterate a lot, but they don't do it up front. I think the style of interaction that it's partly the interface, it's partly the speed. The style of interaction that people use with this is type something quickly, see what you get back, and then refine it if that doesn't work. Query content. In information retrieval literature, Amanda Spink has done a number of analyses of the types of queries people issue on the web, and I don't want to go into the details of the differences with this. The only important thing to note is that we do capture the query strings, and I analyzed several thousand of them by hand, and almost 30% of them contain people's names. So people are incredibly important in retrieving your own content. And that's a case where some named entity extraction might be really useful. If you could identify named entities in the content, it might actually help sort of re-ranking or highlighting in the summaries various things that have matched. Okay, I want to talk a little bit about the characteristics of items that people open. So I said before, we don't really know anything about the size of their store or the content in their store. We do know some characteristics of the items they open. So mostly people open email. And I don't know what it's like here. At Microsoft, people live in email. I don't know how much time you spend in email, but email has become the transport for everything. People are attaching files. We index the attachments. So people are really mostly using this for email. Web pages turn out to be more popular than files, which I was surprised at because web search is so easy. You pull up a browser, and you can research for things you've seen before. But people tend to use the stuff I've seen system reasonably frequently for that. The distribution of age of items open. So 7% of the files that people open were things they had first seen today, which is amazing. I mean, you'd think you knew where it was or where you had put it. You see an item today, you still use this to search for it.
Reopen.
Reopen, yep. Yes.
Yeah.
These are, you reopen things that you first saw today 7% of the time, which again is somewhat surprising. You think you know it's in your inbox or you know exactly where you put it or it's in the folder you're working on. But people are still using this to search. And this is a standard fat-tailed distribution. You can fit a linear function in log space. This is just the function. One of the interesting things is that different types of data have different half-lives. So the half-life of a web page is something like 11 days. The half-life of an email message is about 30 days. And for a file, it's something like 90 days. So the slope of this function changes depending on the source of the input. And then what else? Oh, we did some surveys, and people say they find things faster after they use the system than before. And this is just that survey data. So people claim it's easier to find files, email, and web pages after they use the system, which is not surprising. Let me talk a little bit about some of the user interface experiments. The first experiment we did, or these are different systems that we deploy. So these two differ in whether they have also to the widgets here or on top. This is the one I showed you. This interface allows you, what do we have here? Relevance measurements, okay. Good, we'll dismiss that. Don't you think Windows would do something so that they didn't pop up announcements like this in the middle of presentations? So these interfaces differ in their the richness of the queries that you can issue. Here it's really easy to issue a query that says I want web pages and files. Here you can't do that. So you can issue more complex queries here. The trade-off is that this is a clunkier looking interface, and you do take up a fair amount of the screen real estate for the controls. Okay, another experiment we did was to whether we showed previews or not. So for some people, we turn on the previews automatically. For others, we don't. Again, the trade-off is you see more detail about what's matching. Here you see more of the items. Okay, and then the last experiment is we sorted the results by default, either by date or by this probabilistic best match score. Okay, so again, we randomly deployed these 6 different interfaces to people and just saw what they did differently with the different interfaces. There are really small effects of whether you use the complex or the simple interface and whether we turn previews on or off. In both of these experiments, people start with the top interface. They'll use the side sometimes. They have previews on. They'll turn them off. They'll put them back on. It may depend on the nature of the query. There's no strong preference for one or the other. The thing that had the biggest effect was whether you sorted by date or rank. In all the years of doing sort of human behavioral experiments, this is, I think, the only case where people went away from a default consistently. So even people who had sorting by rank as the default more often sort by date. So for your own content, date turns out to be a really important way to organize the results. So earlier somebody asked about doing fuzzy matching. We have all this fancy probabilistic matching, and it doesn't really matter for this because people know lots of other attributes about things they're looking for. And so I think the best analogy is there really are very few searches where you say, I want to find the best mail from Eric Brill about question answering. You want to find the mail that Eric sent last week or the mail that he sent about a certain feature. So you tend not to want to find the best mail about something, but rather a mail that has attributes that you can use to filter and query.
But there is misspelling, isn't it? And you would want to find it if you go with misspelling.
Okay, so since you're searching on people a lot, that data is pretty clean. The metadata that comes from email especially is actually very clean.
But you may forget how to spell it.
Then you just put in the first name, put in Eric. You'll find it. It'll show you all the Erics you have. So you're right, you could type in Eric Brawl or something, and it would fail to find it. And that's probably something, we should probably do better spelling correction than we do. The way people handle that is you'd get very few matches. You'd say, maybe I spelled this wrong, let me try Eric. And then you see everything from Eric. You can look down the list of people and filter in that way. So, yeah.
Okay, I'm just thinking that Hoffman can have 2 Fs, 1 F, 2 M's, 1 M.
Yep, you're right.
Any combination
Yep.
of this.
Yep. And if I want something from Thomas Hoffman, I'll probably look for PLSI.
I see.
Okay, so yeah, you're absolutely right. Yeah.
Whether Thomas.
He has
How
2
many
Fs and
Fs?
1 N, I think.
Okay, well.
But you're absolutely right. We could probably do a better job of some spelling correction. In the fuzzy search, we do some simple kinds of stemming, and that's where we should probably add the richer spelling correction.
If you have time for a question.
Yeah.
So I think you're right that if you're looking for a particular email or
Yep.
web page or something, data is helpful. Sometimes, some small percentage of my searches, so they may not show up in these kind of aggregate statistics, are looking for all of the mail of a particular type that I've sent, or, all the notes that I've taken
Right.
to myself about something. And in that case, relevance actually might be important. I think
Yeah, you can certainly sort by it. You can certainly sort by it. That's actually an interesting point. What we should do is look at queries where people have changed the sort order. So imagine you're first sorting by date and now you sort by relevance. It would be interesting to go through and look at those queries to see if there are characteristics of them that look more informational than they do sort of specific item.
Yeah, I agree. What I was thinking is that for those kinds of searches, a hybrid interface might actually be useful.
Well, you can sort by rank here perfectly well.
No, I understand. So there are two kinds of hybrid interfaces that I can think of.
Right.
One is where you take the rank to incorporate recency. So you just hack the rank, take
Right.
some linear combination of rank and date.
Yeah.
But the other is, maybe you still want to sort by date, but use color or boldface or something like that to
Yes.
indicate the ones that seem particularly relevant or irrelevant.
Yep. Yeah, so one of the things we've done in the interface so far is kept all the attributes separate, and that allows you to quickly sort on them. Because I think for many searches, people remember specific attributes, and they don't want that sort of munged in some combined ranking function. But one of the things that we should look at, especially for usage patterns, is ways of pulling out things that people are likely to want to go on too quickly, and then still providing the control if they want it. But yeah, we so far have avoided having a single ranking function that combines all of these attributes and rather expose most of the attributes directly.
Right,
Yeah.
there's a lot to be said just for computing. Most people, not being these, know what the data is and don't know the rankings or what it means. I mean, you can see that it's some dissenting number.
Right, but you search on the web, you don't know how those things are ranked.
Right, but you don't select it and there's,
Well, but so for half the people, they got it as the default. So every search they do is by default ranked that way. And they will still change away from it. And actually, those data have gotten even more distinct. I mean, almost nobody sorts by rank. And it could be our naming of it. It could be that the ranking algorithm doesn't really work for your own content. But it is a pretty startling effect. And it could be that we haven't come up with the right combination function. Okay, let me just, there are a few observations about unified access that I think are interesting. The first is, so one of the things that we did in this project is bring together data from lots of different sources. Right now, when you look at web data, it has a different interface than when you look at mail. And there are a number of things that happen when you unify access. The first thing that is really apparent is that metadata quality is very variable. So for email, it's reasonable. It's actually pretty rich and pretty clean. You have a sender, you have a title, you know the date, you know whether it contained an attachment, you know whether you replied to it, you know if you forwarded it. You actually know a fair amount about it. The web has very little metadata that's consistent, and very little of it is useful for retrieval purposes. So you probably don't care how big a web page is or how often it's updated. There are some metadata attributes that you can get, but most of them I think are not so useful for retrieval. Files are actually the worst case because there is some metadata, it's just usually wrong. And a lot of the applications don't do very much to expose to you what that metadata is and how to add metadata that's right. So it's actually one of the big frustrations of trying to integrate files and email. The author of almost, more than half my papers is Keith Instone, because he wrote the template that I use for a lot of ACM papers. And so if I search for papers that I wrote, Keith comes up a lot. And then you could always have human annotation, and we are exploring, I'll mention at the end, a system that allows humans to do some tagging, but don't depend on it. I mean, people are just not going to tag everything unless it's part of the application proper as it is in mail. Okay, another thing is we discovered we needed an abstraction for date. So I said date's really important, and what we did initially was to sort everything by the date that it had been seen, last seen. Okay, so we're going to sort email by when you last saw it, files by when you last saw it, because we have only one column for date, at least by default. That is absolutely the wrong date to use for calendar appointments.
What date is wrong? I'm sorry.
So for calendar appointments, you think of them as the day they happen. You don't think of them as the day that you received them or the day that you said okay to them. And it was something that, again, you deploy it, people said, you lost my calendar appointments. And we didn't lose them, they were just at the wrong date. And so what we've done is come up with a concept that we call useful date that's an abstraction that's populated by different fields depending on what the native source is. So for
you have to put it in.
You as a user do nothing. We as the system designers say,
Because you will find in the text that somebody wrote you email which says you have an appointment on such and such.
so in email, it's really trivial because that's the date that's associated with the appointment. And at least
So
in
you will look
Outlook,
for it in the email.
it's a metadata field in the email. So there's nothing interesting that we're doing. We're just pulling out that
No, I
metadata.
don't understand.
No, so-
So in Outlook, you can actually send you I can send you an appointment that says, shall we meet Thursday at
I
noon?
see, but I'm not
Right,
using our.
okay. So if you do that, then it's, so if you do it in Outlook, let me see, most of our users are using Outlook, but it also works with Hotmail.
But
I mean,
they
you can-
suffer for it by viruses, right?
She was not aware.
No, so what you're saying is that
But and you could you could extract it and try to do it that way, but it sort of comes for free in the application. In the same way that I know who sent it to you. I know that you don't have to tell me who sent it to you. And most mail applications probably have some notion of appointment date.
But I mean, I think Fred's bringing up the
Yeah.
point of you could do extraction.
Absolutely.
Extract metadata.
Yep, absolutely. And so in any of the filters that you write, you can do extraction to extract named entities of various sorts, dates, and things like that. Yep. You could absolutely do that. We tend not to do much of it. We take only what's given easily by the applications, but there's no reason in principle why you couldn't do that. Did you have another question? Okay, so one of the things that because time is so important, one of the things we wanted to know is what people remembered about time. So how do you remember the date that something happens? How do you remember when something happened? There's actually a fair amount of literature in psychology that talks a little bit about some of the principles of human memory. And one of them involves a notion of memory landmarks. So for some recent things, you might know that it happened Tuesday. For things that happened 2 years ago, you might remember, oh, it happened before the start of fall semester, or I know it happened just before I went to the ICAST meeting. And so you remember it relative to landmarks. And so one of the things that we did with a summer student last summer was develop an interface that capitalized on the notion of landmarks. So instead of showing you just a big long list of things, we tried to put in these memory landmark hooks into the interface. And we use two general kinds of landmarks. We use general landmarks, so on a calendar you know whether it's 4th of July, you know some common dates, and we also had some world events that we could extract as being important. And then we use personal landmarks. These are important photos and appointments. And we determine the importance of, let's take appointments, heuristically. We model the atypia of those appointments given your other set of appointments. So if you're usually in the office and this meeting is out of the office, then it gets some score for being atypical. If it's you're usually in short meetings and this is a long meeting, then you get an extra boost for that. So we had a handful of heuristics that, that described whether an appointment was likely to be important or not. We've since then built some Bayesian models. We've had a half dozen people go through their entire appointment history for 2 or 3 years, label every event as memorable or not, and then learn models that predict that it's actually not that horrendous to do. Most of the stuff on my calendar is not very memorable. And so we then built Bayesian models of what features predicted whether items were going to be memorable.
So you have world events? What kind of world events?
So these we cheated. We got them from Encarta. Encarta has important world events, and so we just took those. You could do things like analyze news streams and analyze sort of the kinds of bursts in data that John Kleinberg has looked at. If you know that. So you could look at changes in rate of occurrence of words and identify things that are likely to be important events. Or you could just look at the number of news articles about them. But we cheated on that one.
And important photos, is that the day that you receive the photos?
Important photos, yeah, I mean, each one of these, sort of how you pick out importance is sort of a whole research problem on its own, and we took one pass at it for this. So for photos, we used some techniques that John Platt had developed. They're techniques that, first of all, segment your photos into temporal groups. So you typically take a bunch of photos, then a break, and then a bunch of photos. So you first group by time, and then within that you pick out I think you picked out you can pick out the typical photos based on color histogram analyses. So we pick out from a clump the most typical photo in that clump. And one of the things that people said in our experiment is that they wanted to pick out their own photos. So we could let them do that as well.
I don't understand it.
Okay.
In other words, I would have to enter into the system. Then what does it mean that I'm going to pick out my own?
Oh, so for these experiments, we did everything automatically. So you give us access to your computer, we'll pick out what we think is a characteristic photo from your photos. People, when working with the interface, said, gee, you know, I know this is a photo of my trip to Greece, but I don't like that photo. I want to put in my favorite photo of the sunset. So can you let me put that in for that event? So and I don't know if they would do it in the real world, but in our
You now are
laboratory.
saying, I must be misunderstanding. You now are saying that let me put this in there for that event. But actually, I don't know when I will use the photo as a landmark. I don't even suspect I will ever use it.
Right, so if you never do, we'll pick out something automatically, you'll never see it, you never have to do anything. If it turns
I don't
out,
have to do anything, but then again, I might not find it.
so again, this isn't
You know,
photo.
I know that
again,
this happened before, well, I was going to say before March, but that's trivial. So I know that this happened before my trip to Greece.
Right.
So I would write in that,
No, you never write in anything. We'll
then how
decide.
will we find it?
So
If my memory is that I want some email I got from Sanji
right,
before I went to Greece.
right. So I mean,
Then how do I
here's,
specify it?
you do not specify anything. You just type in Sanjeev, and let me show you the interface. And I think let me show you the interface. I think it'll become clearer. So you do a standard search. This search is for earthquake, and you get back a bunch of stuff. Okay, this is a standard timeline view. You see some recent things at the top, and then a bunch of others over time. One of the things we added here was this distribution of events over time, so you can actually see when there are clumps of items. There are clumps of email about earthquakes shortly after earthquakes happen. And so you see some of that. Now, the landmarks, you don't ever search for a landmark. They just come up automatically, and they're linked only by time. So here's an email from somebody talking about the earthquake in Seattle, and it happened exactly at the same time that the Seattle earthquake happened. And all we do is link by time. Okay, so you never specify a query. You don't say, I remember that it happened relative to a landmark.
I see it displayed there, and I find it.
Yeah.
And the thing that's displayed reminds me of time
Exactly.
period.
Yeah. So it's a standard search, and then you have these landmarks into it. Now you do raise the interesting question about what if I know it came before a certain event? Can I specify that? And we haven't looked at that. That's actually a really interesting thing. So you say, I know it happened fall semester. And we don't allow any way of doing that right now.
It happened before I went to Greece, and I'm not going to tell you when I went to Greece.
Yeah, exactly.
Yeah.
And it doesn't
Yeah.
mean 10 years before I went to Greece.
Yeah. Yeah. So that we don't have a very good way of doing it. So here it depends on us picking out things that at least sort of correspond roughly with things that landmarks that are relevant to you. But it's an interesting new way, I think, of organizing information, not just by yeah.
So another stream that might be useful for these landmarks, some people keep weblogs or research diaries electronically.
Uh-huh.
The data is relatively formatted. You have to do some extraction or something.
Yes, so for that, that should fit in nicely with this. You could just write a different protocol handler that specified what a unit was in a blog, and then do the same sort of thing. And so you could have in here sort of blog dates or blog links. Yeah. Okay, so, and we did some lab experiments of trying to retrieve information with just a standard timeline or with some of these landmarks thrown in, and people are faster at finding things when we have the landmarks.
What kinds of things do you have them find?
Yeah, oh, that was a detail I was going to go. So in all of these experiments, it's really hard to do a standard kind of corpus, a standard kind of search. I can't say, here are the 30 Trek queries for this year, please find them. You have to work with people's mail, or people's personal stores. And so for this experiment, we did two things. One is we asked people about information that had been sent out company-wide. So we assumed that they would have received it. The other thing we did is ask them to send us their calendar appointments, and then we made up queries that we thought were relevant to their calendar appointments. So we tried to do some more personal things. So if the calendar entry said SIG-IR meeting, we might ask them a question, find your travel arrangements for the SIG-IR meeting. Okay. And that's really hard to do. I mean, it's really hard to ask meaningful questions of people that are based on their stores.
These 1,500 people who are using this right now,
Yes.
Have they been given the version which has?
No, this was done only in the lab. So we've only studied this in the lab. It just isn't robust enough right now to go out to 1,500 people.
So are those pictures that I see pictures that I took, so to speak?
Yes.
Or if I went to Greece, would you put in a Greek picture?
No, those are pictures that you took. Those are pictures that
I
you
didn't
took.
take any pictures.
Those are pictures that you took.
Oh, this one.
Yeah. So yeah, again, we're depending on everything being digital for this. There are certainly lots of extensions that you can have.
It seems like, I mean, you could generate pictures for Independence Day.
Yes.
Father's Day.
Yeah.
I
Yeah.
mean, at least the calendar.
Yeah. So right now, these are sort of these things are sort of the calendar events are not represented in any good way. You could even just go back to news streams that have them and pull out some. So you could do a lot more pictorially.
It might be useful to allow people to add the extensive time, like my vacation to Greece, fall semester of 03.
Yep.
I was working on
That's
something
interesting.
project. And
So you
that
give
way-
a date range for things, yeah.
And that way you can search by it or also view by it.
Yes.
Does Outlook support date ranges?
I beg your pardon?
Does Outlook support date ranges?
Outlook may or may not, but our query interface does. So you could say only stuff. So in Outlook, you certainly know the date that something happens, and events can happen over time. You can say a begin date and an end date. So yeah, they support date ranges, and we can query over date ranges.
Okay, so if somebody has, something that says in Greece, they've got a week long.
Yeah, and in my case, that's how some of the things wind up on my calendar as being atypical, is that I'm out of the office for long periods of time. Yeah. And I don't often put Greece, I'll just put maybe SIG-IR trip or something. Or even just vacation. Okay. I'm going to skip this. This is a section on some abstractions that go above and beyond individual search results, but I want to talk about some further extensions. So this is not a great visualization, and it's just a way of collapsing so that you don't see individual search results, but rather summaries of trends in the data, and I can go back to it if people want later. So one of the other things we've been doing recently, so now that you have this search infrastructure over your content, there are a variety of things that you can do that I think are really interesting in thinking about how to support people's information management needs. And one of them is what we're calling broadly contextualizing search. So putting search into context. And by that I mean that for most people, search is not the end goal. You are not searching to go out and spend 20 minutes searching the web. You're doing it because you're writing a paper or because a deadline's coming up. You're doing it because you're doing something else. And right now what happens is the way you search, we'll say on the web, is you stop everything you're doing, you pull up a browser, you search, you find what you want, you put that away, go back to what you're doing. And so it's sort of a very uncontextualized kind of application. So search is not part of what you're doing. It's a separate activity. And so one of the things we're looking at is trying to make search much more part of the activity that you're always doing. One of the things I didn't show you is we have a little taskbar here that's constantly available no matter what you're doing. You type in a query there and it brings up the stuff I've seen interface, okay, with your search results. Another thing we're doing is looking at being able to search from within different applications. So one example of this is a plugin that we've written for various office applications. You sweep out a region. Here I swept out Bayesian models. You right click and then I can search stuff I've seen directly from the application. So I don't have to pull up a separate retrieval program. Another one is with the new version of Office, there's this little thing here called a research pane that will search over dictionaries and other data sources. It turns out that stuff I've seen is just a data source, and so within any application you can search and see all the results come up right next to the application. So again, you don't have to switch focus. Okay, so the idea is just to try to make search much more a part of what you're doing. And the most extreme example of that is something called implicit queries, where we try to proactively find things that are related to what you're doing without you ever doing them. And I'm going to do a slideshow demo of it, and then I'll try a live demo as well. So the idea behind implicit queries is here's an email about a new prototype that somebody in our group has developed. As you're reading the email, what we do is, first of all, pull up this, we create this little sort of sidebar, and we make a variety of quick links. So you can, with that sidebar, find every other item from this person, every other item on this topic, just a click away. Then the other thing we do is analyze, doing sort of various kinds of statistical analyses of this document, pull out important words and automatically issue a query for that and show those results in a separate task pane. I think this is actually more fun. Okay, I'm going to try it live. I have a bunch of, let me bring up an Eric Grill mail in honor of Eric. So here's a mail Eric sent me. I'm sitting here like doing nothing, and hopefully it'll work. So it's analyzing this, and now it's picked up a bunch of things that are related to this.
Tell me what it picked up, I can't read.
Oh, so what words it picked up were demo fails is two of the words.
He has the word demo fails.
Yeah, so somewhere, so
I mean, I
it's
can't read what he
right.
either, so.
Yeah, so what it does.
Demo fails.
So what it does, yeah, so this is an email he said, I think, you know, I sent him mail saying I think this demo's working, and then these are mails that are related to this email. And it picked out words, port request, which is the name of the search server we use, demo fails, ask MSR, which is the name of the question answering system we were working on, usable downtime. So it picked up a bunch of other things that were related to this. And exactly how you pick out those items, how you surface things. Actually, so we can actually reply to him, and as I'm doing anything, they say, you know, hi, Eric. I'm at, and it's just going to change things that it brings back. No, it's not going to. Yeah, we can just go on. So as I'm typing or working, it's always finding things that are related to this one. So I'm not connected to the network. That would be fun though. Yeah, if I was, I could do that. So you know.
So you would JHU might be popping up, but
yeah, exactly.
It doesn't have to be.
It probably does. So let me spell it. I probably never abbreviated it. What's the name of the center? It's Center for Language, CSLP.
CLSP.
P is Center for Language. It doesn't matter. It's all imprecise. So eventually I get, you know.
But you didn't do anything, right?
We didn't do anything yet, but eventually I get your mail about trying to set up a.
You know, you're old mentor, and that's where I would like you to
Okay.
find center anyway.
Yeah, exactly. And so, yeah, we can certainly do things like that. So this is just an example of something where, you know, you're not always going to find useful stuff off to the right, but it is a different way of surfacing things that are related to what's ongoing. And so it's yet another project that's facilitated by the fact that you have this really rich index underlying your content. Yeah?
Are you ranking those by the rank that we saw before, or?
Oh, yeah, that's actually a really important point. So we're ranking these not by, so before I said we ranked by time, here we're ranking by quality of match. So here what we want is stuff that's related more topically. And again, we could probably do a better job. So it's mostly based on content. There's a bit of a time factor in there as well, but we could probably do a better job of the ranking. We didn't want that window to become the search pane. We didn't want you spending all your time in that window. We wanted it to really be much more of a peripheral awareness thing. So that's a case where we took our best stab at a ranking function. So let me wrap up because we're getting late. So what I hope that I've told you about today is a summary of one project we're working on called Stuff I've Seen, which provides sort of fast, unified access to a variety of heterogeneous information that you've seen before. Psychologically, I think it's an interesting slice of information. Stuff that you've seen is very different than what most search applications now support. And then we've studied usage with several different techniques. Some of the things that we found that I think are interesting and unique in this line of work are the importance of people and time in the search. And then we're, again, looking at a number of sort of novel interfaces in order to leverage the fact that this is your personal content. So some of the next kinds of things that we're doing include sort of continued explorations of rich UI, continued explorations of really trying to surface things that you want when you're working so that you don't have to continually stop what you're doing and explicitly ask queries. We're looking at techniques for identifying stuff I should see. So imagine, given everything I know I'm working on, going out on the web or on the corporate internet and finding things that are related, even though I would never think to ask about them. And then the last one is something that I've mentioned a couple times today and people cringe, but it's something that we call flatland. And the idea is, right now, computer systems force you to store something somewhere. They force you to give it a name and put it typically in a file hierarchy. And that, I mean, we've all gotten used to it. I don't think it's very natural for most of us. But when you have good search, it makes filing less important. So we have a number of people who are using stuff I've seen who have not filed anything, email or a file, in over a year. They just depend on search in order to be able to find it. And one of the things we're looking at is where that breaks down. So even those people, even the people who are willing to live in flatland, would like to have some ability to tag things occasionally. So they want to say, this is related to my TA-ship for this course. I'm willing to tag it. I'm willing to tell you about it. Make sure that I can retrieve it with that tag. But for the most part, they're willing not to ever tag anything and just depend on search in order to get it back, which is, I think, a really interesting, different way of managing information. There's no reason to think that the hierarchies that we're stuck with today are particularly natural, nor the file cabinets that we've lived with for decades. I was talking with Fred earlier, and he's saying that one of the problems with file cabinets is that things live in one place. And if you want to use it, you make a copy of it, and then you might forget to put it back, and things are all over the place. Electronically, you have much more flexible means of accessing information. And I think this kind of system will just really push some of those frontiers. So again, you can get a lot of information on my homepage, and I'll be glad to take lots of other questions now.
Yeah, so once you, well, I've asked more questions, so but hold on. So yeah,
One question is related to A, the fact that a lot of what people are looking for is known item, and B, that you really don't want to know where you put it, but it would be good if you could identify it again. So there is the result that Robert Weinstein found where he could identify anything on the web uniquely with a 5 to 7 word Google query. Do you think stuff that you've seen is similar, each thing is similar to the other things, that you would need a longer unique identifier as a way if you always wanted to recover?
So that presumes that you want to. That presumes that you want to get back only a single item. It's quite easy in this interface and even on the web to get back lots of items and then select the one you want. So it's an issue of whether you specify upfront all the constraints or do it only once you've seen how much sort of an initial broad-based query gets you.
Right. This is sort of an artificial question. It's not, what people would choose.
And I don't know the answer to that. I don't know the answer. It's an interesting question. We could certainly. I'm willing to do an analysis of it on my content. I don't have everybody else's content. I would be willing to do it on mine. It's not clear how to handle email threads, things like that, or different versions of a document. Ideally those would be handled in versioning systems, and you wouldn't have to worry about it. It would be the same object with slightly, with deltas.
Well, or what Fred brought up, or there are certain kinds of things where you want the latest version, and certain kinds of things where you want a
But it would still be nice to know that those are canonically the same thing with variations.
Well, and then you could do queries based on volatility.
Yep. Yeah, that's actually an important thing. One of the things that we are looking at, I guess I don't have it on this slide, is the notion of incorporating much richer usage data. So right now we're not taking into account the fact that you've opened an item 43 times in the last week, or that you sent mail to somebody and attached it. So we don't know anything about the usage patterns. And
you see that in the distribution.
You see it in the distribution of time, but you don't see the same item repeated over and over and over again. Right. So if you've opened an item lots of times, we'll take the most recent open date. We won't put it in all of those places. So that again is, I think, something that we need to represent, and then we need to worry about how to display that to users in a way that they understand it.
You mentioned that over 50% of the time people iterate over the search that they...
Yeah, I think it was 48%.
48%.
Yeah.
So it seems there is, you could, in principle, use the iteration that people have gone through to cluster items as well. There is useful information in that iterations, in those iterations as well. Like for example, I sent a query, I listed a bunch of things, and I iterated, I selected an item. So you could potentially make use of the fact that the person looked at a bunch of things and selected a sequence of articles from that.
Well, so when I said iteration, I meant actually iteration on the query.
Right.
So an iteration on the query might be, no, I only want to look at things that happened this week, or I only want to look at email items. So I'm not talking about interaction patterns with the items themselves.
Oh,
Okay. We don't store that. That's all on the client. So all we know is the nature of the queries, the nature of the user interface interactions, and then a tiny bit about things they open. So we do know the date and type of things that people open. So we could certainly record all the items that they open in response to a query. People tend not to open very much in response to a single query. They hone in these other ways. Again, this is your stuff. You tend to know what's there. So it's not like you say, oh God, did I ever write a paper with my email address in it? You tend to know a lot about it. Yeah.
You can dynamically index or re-index email.
Yep.
How costly is that?
Not bad at all. It's a bit of a problem for laptops. So performance is the number one issue. People, especially on laptops, don't like their disk spinning when they're doing nothing. And your disk will spin a little bit. But just think about the amount of mail you get. What do you get, a few hundred mails a day? How much text is that? It's really nothing. It's just
Do you index the spam and viruses that come in?
I do. I have all my spam, sure.
Mm.
But I don't search for things that usually appear in the spam. I actually specifically...
Well, that's you. I mean, I always want to know.
No, I specifically... Well, then it would be there for you, right? So I specifically actually save my mail in a folder called spam that we use for training spam filters. But yeah, we index in real time. It's not very heavyweight. On a laptop, we don't index when you're on battery power. So when you reconnect, we have to catch up a little bit. But it's really not much of an overhead. The biggest hit you see performance-wise is when you do this initially, you're allowed to say, I want to index all of my mail in my default profile or all my mail in certain subdirectories and seed it with that. And that takes a few hours.
And it all assumes that everything you own is on the computer, on the...
It doesn't have to be here. It could be on the web, or it could be... A lot of the mail is indexed is on a lot of the mail I can't open because it's on the corporate network. I don't have access to that right now.
But you index it anyway.
Yes.
Because
I saw it on this machine.
Or because you saw it on the machine.
Yep.
So everything you saw, you do store there?
Yep. But we don't store the content. We store the index that gets us back to the content. So it's just like you don't store all of the web on your machine, although you can search for it.
I see. So you're going to see that it has such and such a context, and then you have to retrieve it.
Yes. Yeah. So it lives wherever it lives. If it lives in the database, it lives there. If it lives on a remote server, it lives there. And whether or not you can access it depends on what you're connected to at the moment.
Yeah.
But at least you can know that you have it. And sometimes in the summary, which we do store locally, there's enough information to answer your question.
So I, for instance, may not be connected to the modem or whatever.
Right.
But if I search for it, it will come up.
Yes.
And it will tell you if you want to be very connected.
Yes, or it tells you something not quite that
Well,
nice.
I don't mean that.
It tells you something nastier than that.
Oh,
Yeah.
nastier.
No, it just says, can't open, blah, blah, blah. We haven't worried a lot about error messages. It just says, can't find item.
You should worry about it.
We should.
My wife gets tremendous.
No,
My microphone error is fatal error. No, this is serious. She doesn't believe that she's about to die, but she does believe that maybe she killed the computer.
Yes. No, and you're absolutely right. Given my training as a psychologist, I should worry a lot more about the nice error messages. But we just say can't open store or something really lame.
I have two questions. One, you said names are important in all these searches.
Yep.
Now, you do have access to a lot of names by way of your email repository. Do you then try to use them to index names in the other documents?
We don't do anything like that right now. So that's actually an area where I think some of the experiences you have might be, we don't index names specially, and we don't use them in the ranking. So that's a case where I think you might be able to do some more interesting named entity extraction. And I said names are important only because if you look at the text of mail, a lot of it is people's names. And I think what that suggests is that people remember something about who sent them information. So if you're looking for email a lot, I'll remember who sent it.
So you think that the 30% queries having names is because the queries themselves were trying to get to email?
Yeah, that's what people remembered about it.
Okay.
That's what people remembered about what they wanted to find.
Okay,
Is it
but
somebody-
if it's the sender, then of course you don't need to index the content, because the sender is a separate piece of
Right.
data.
And we did, yeah, and we support you doing that, but, yeah, we support you restricting the search to sender or recipient, but most people don't do it.
And I have a unrelated question about landmarks. Now, picture the one set of landmarks which are nice.
Right.
There are also other landmarks which are in the email content. You might get a letter saying, that,
Important, or,
no, congratulations,
Uh-huh.
you've got this and that, or whatever, a raise or a bonus or something, or I don't know.
most of
So
the
you might get 20
congratulations.
email messages from friends saying, oh, congratulations on the baby and something.
Uh-huh.
So that's clearly a landmark, and there may actually not be any pictures about it until 2 weeks later.
Right. So there is a related system. Are we on the home page now?
Yes. 2 weeks later, right? Lift it up.
So Eric Corbett's, who some of you may know, has done some work on trying to prioritize email. And he tries to do that based on all sorts of characteristics about it. Things like how quickly you reply, who's involved in the email. If it's somebody who's 3 levels above you in the organization, then that might be a priori more important. And so you can imagine using a system kind of like this to automatically identify a prior on each of the items.
But how would you show it in that interface?
I don't know how to show it. I don't know how to show it. I don't know whether it's a separate tab or you somehow make it bigger or bolder or devote more screen real estate to it. I don't know that. But I think you can compute things that are likely to be important based on activity patterns. And you'd miss some. You'd miss that you won the lottery again.
Right. So search is one part of the kind of interface you need to deal with information overload.
Yeah.
And it goes hand in hand with filtering, which I think is what you
Right.
are doing with Stuff I Should See, and also browsing, which you haven't talked about. So browsing seems especially, there are 2 places where I can see that fitting in here. One is if I click on an email message after I've done the search, I don't know what I get, whether I get the appropriate passage of the email or if I get the entire thread.
Right.
But let's suppose that I'm in flatland, right? So
Yeah.
I'm getting back a document. I might want to be able to navigate to related documents.
Right. So
Or that's
we,
defined implicitly.
yeah, we actually have some of that implemented. So one of the things you can do is right-click and you can go to the item, which is the default behavior, or you can actually go to the folder containing the item.
Which doesn't help if you're in flatland.
It doesn't help if you're in flatland, but it could be, things that share the same metadata attribute or things that share the same sender. In another interface, we have essentially find related. And so this is find related by where they live in my file system, which I said is something we want to consider getting rid of. But it could be find related. They happen at the same time. They're from the same sender. They're clustered in some other way. So I think that's perfectly consistent with this. We don't have a good story for just using all of those attributes coming from multiple different dimensions in order to browse. One of the nice things about a file system is that it gives you a primary hook into things, right? And so that we don't have when you have multiple attributes. Marty Hurst has done some nice work on, what does she call it? Multifaceted browsing and retrieval. So she's done some things where you can browse and search on information that's organized by multiple attributes simultaneously, and we could certainly employ some of those ideas here.
Yeah, I mean, there are I know some work, like the scanner gather stuff for integrating browse and search.
Yeah. But that again is a single dimension, right? So that's
yeah, no, it's one cluster.
Yep.
It's not
Yep.
anyway.
Yep.
So I'm sorry, I didn't mean to
Yeah.
make that, put that in the same thing as Marty's work.
Uh-huh.
But what I'm wondering is how much of this browsing, how much of the work in browsing has been applied to these personal information collections, stuff I've seen collections. So all the things that I've seen have been, stuff you haven't seen before that's out on the web.
Right.
And
That's
there
really
might be-
interesting, yeah.
Yeah.
Yeah, I don't know anything, I don't know the extent to which people have looked at browsing interfaces.
Well,
Somebody
I'm
did it.
planning to work on it, because I think this stuff is terrific.
Yeah.
I'd like to have it, and I'd like to have browsing built in.
Use Outlook.
So when do you browse? When do you browse?
When do I, mostly when I'm trying to, so I teach a course every fall, and I'm interested in being able to get all the complaints that I had about last year's version of an assignment so I can revise it this year.
Okay.
That's an example. Another is, I know I've been talking to a number of people about some, group of ideas involving a project that I'm working on, and I'd like to find things that are relevant because I'd like to pick up and think about that idea some more, or that group of ideas, and I need to find all the relevant stuff.
Okay.
And
you
I'm
find
also doing
browsing-
this stuff by organizing it myself. So I spend a lot of time tagging and indexing, or putting stuff in the same folder, in the same file, in fact, and just adding it to the right place.
Right. So, you can search by all of those attributes here. You can say like path equals and specify some part of the path.
Yeah, but then I've got to organize it.
Then you have to organize it.
And I also have this stuff.
Yes. But that's maybe where the implicit query would help. It actually would find things that are related that you may have put in weird places.
Yes, ma'am.
Yeah, it may help. Any other questions? Yeah.
Yeah, sort of along those same lines. Another nice thing about a file tree is that you can see absolutely everything that's in maybe someplace on your computer, and it's not mediated by search in theory. And I'm wondering, do you find that users don't care about that?
No, users are panicked about going flat. Most users are.
So, how do you think that we just don't need that, we just need to get over it, or how do you handle that?
That project's at a really, really early stage in development. And so I don't know, I think you want to do what makes most sense psychologically, what makes it easy for people to find things. And if it's forcing them to put things in, to add metadata to every item they see, then that may be the way to do it. If they're comfortable with search and sort of multiple attributes as ways to get at things, then that's what you want to support. So I honestly don't know the answer to that. But I think it's interesting to explore another part of the space. And right now we're pretty stuck on put things in a folder. And we're not the first ones to think about this. Folks at Xerox PARC built a system called Placeless a number of years ago that explores some of these ideas as well, although I don't think they deployed it very widely. They built the infrastructure too.
Do you have any support for search of document substructures such as an abstract of a paper, a caption in a web page, photo, or excluding quoted text and email?
We don't have any of that right now. The way you would handle that is to write a protocol handler that said, I don't want to index individual mail messages, I want to index, or individual documents, I want to index the title separately from the abstract, separately from section 1, and so on. You can certainly search for some of that metadata, but we don't have it.
There's no hook in there.
There's a hook in there, but we don't capitalize on it right now. And that's especially useful for things like PowerPoint slides, where you probably want to find a single slide. You don't want to know that, hey, this isn't your deck of 300 slides. So that might be really nice in cases.
When this is a product,
Uh-huh.
how will you tell people, what it has, etc.? Are you going to write an essay or, is there a problem? Is there a problem with the manual that?
Right. So actually,
if one has to go around and.
Yeah. So one thing I'd love to see is the following. See this little box right here?
Which box?
This guy right here.
Yes.
What would you do if you saw that box? Type into it, right? And if you type into it, you get stuff back. So that's one answer that people are more and more used to search. And I think 10 years ago, the only people who did search were professional librarians. And now much more people are used to that as a way to find things. So, I can find everything I have about JHU here. It's really bad. Okay, so there's a bunch of things. Travel to Gaithersburg, Dumais visit. Okay, so those are, so I just typed in that little box. And you're right, the interface here is way more complex than it needs to be. But I think having things like a common entry point is a reasonable way to start. It's not a great answer, I'm sure.
No, in the regular Windows, when I look at help, it says, so I put some item in, and then comes a list, and it's not there. Right? So now I don't know whether the thing I'm looking for is not there, or the name that I attached to it, an unfortunate name, and if I only was clever.
So actually, let me tell you an interesting thing about that, which I think will get better. Most of you have probably grown up searching the web, right, and always think about search being available in a networked environment. Search for help on a machine, whether it's a Unix machine or a Windows machine, is all local, right? You can struggle for an hour trying to find something, and nobody's ever going to benefit from that. I mean, you'll eventually either give up or find the help or run down the hall and ask a colleague. But one of the things that's happening now for the first time is that help, when I search for help in Windows or in Office, is going to the network if you're connected. And so for the first time ever, people know what you're asking for. And you can do a lot by knowing what people are asking for. You can write content, you can increase your vocabulary. So I can adapt.
If I search on Microsoft Word but am connected
to the network, it will look on the network. And so if you now type, if you ask, and that's the way that, you know, web search engines are successful because they index not just the content of what's on a page, but all the anchor text that people use to point at it. And so one of the interesting things you can do when you get data about what people are looking for is add a bunch of synonyms. You're getting all the synonyms sort of in situ. You're also, I mean, it's also the first opportunity to know what people are asking about that you have no content for. So I think you'll see better help once you know what people are looking for. I mean, it's sort of a shot in the dark before then.
For those who don't know it, I believe Susan demoed this was it yesterday at Context with Bill Gates.
Sunday night.
Plenary talk.
Yes.
9,000 people.
Yes.
So when is this going to be a product?
Take this offline. So I guess there are a couple of answers to that. One is that we built this as in part a demonstration of what you could do with a very search-centric application. And one of the things that we hope is that people building the next version of the operating system take some of these lessons to heart and make much better search capabilities in the next version of the operating system. I don't think you'll see this particular application, but I hope you'll see search that's way easier than it is today, where you have to remember where you saw something, you have to slowly go through a non-indexed store. So I'm hopeful that there will be some lessons learned.
So is stuff I've seen at Microsoft trademark yet?
No, probably not. So is that big enough? The other thing is there are third-party applications now that do some of this, so you can try out what this is like for, I don't know, $39.95. Enfish, 80/20 data retriever, what's the ideal now? X1. There are a bunch of these. There are about a half dozen of these out. They don't have quite the functionality of this, but you can see what some of these are like.
So I hope you don't think this is a cheeky question. One thing I'd be worried about if this made it into, in some form into Windows, is whether the gatherer would have an open API.
The gatherer already has an open API.
Well, yours does, right?
I think it has to.
Yeah, I mean, I'm a little concerned that somebody
I think
might
it has to. I think
might have to get Microsoft's permission to.
No, I mean already. This basic indexing pipeline already ships with several of the Microsoft enterprise search systems, and so I can't imagine them closing it on the desktop. I mean, that's how Adobe wrote their iFilter, because the API is open. So, yeah. All I can say is that I hope it's open.
We should continue questions, but those who need to leave, we should probably let them go. So please.
Okay, thanks.